Hey everybody, welcome to the next episode of the Better Product Podcast Solutions, bringing you Pjeter Berishaj from Templinks, and go over all the different types of products that they're offering, predominantly chemical indicator types, a lot of information shared on the different types there, market drivers, and a lot of regulatory and compliance conversations of all things chemical indicators and sterilization. So without further ado, bringing you Pjeter from Laco. Thank you. Hello, everyone. Welcome to the next episode of the Better Product Podcast. And I'm pretty excited here because this is now episode 2 in person. So when COVID hit, I went into Microsoft Teams, and now I'm back out of hiding. And my next guest is bold enough to be here with me to be in person. So Pjeter Berishaj from Laco, Templinks, and I'm excited to have you here, Pjeter. And thanks for being here in the flesh too, because I feel like, we could be doing this on Teams, but we went out to dinner last night and we talked about the face-to-face it's so good to be back face-to-face. So thank you for being here.
Thank you for having me here.
Good.
I really appreciate it.
So the softball question on the podcast, tell us about yourself, your role at Laco, and Templinks and Laco.
Yeah. Well, again, thank you very much for this opportunity. I kind of look forward to discussing this topic because I think it's not talked enough about. And let me start with myself. By trade, by education, I'm a chemist. I've got my bachelor's degree back from University of Pristina in Kosovo, back in a very small, young country, and got my postgraduate degree from Wayne State University in Detroit, Michigan. I started my professional career in automotive paints and coatings, worked there for several years, and then in 2007 I was approached by a company in New Jersey, Temple, an ITW company, where they wanted someone to be employed and handle some of the things they refer to them as chemical indicator inks, which I knew nothing about. And that was my introduction to the world of sterilization inks and security inks, where these products are used, what they're used for, and the role they play in the market. So I've been with the company ever since. Laco Industries acquired Temple back in January 2013, and moved to Chicagoland with them, and I've been with the company ever since.
And it's funny, I hear Chicagoland from people from Chicago. I never think of calling it Chicagoland, so I'm going to have to start calling it Chicagoland. So Templinks, can you talk about, I guess, all the different types of products that are in the Templinks portfolio?
Yeah, and it's the core ink products that Laco produces, the Templinks brand would be the sterilization inks and security inks. Those were invented back in 60s when chemical indicators, or indicators as such, were somewhat started to be known, but not chemical indicators that are compliant to multiple functionalities and the conditions under which they are exposed. We make steam sterilization inks, ethylene oxide, plasma or hydrogen peroxide inks, formaldehyde, dry heat inks. And then we have a category of inks that are used in security applications such as money pouches, evidence bags, used by in various applications. And for the last few years, we also have a product line used for general printed inks, but that are more robust and are compliant to a lot of, and are robust enough to be able to handle exposure to very rough conditions such as steam sterilization or other conditions that the packages where these inks are printed on are used.
And on the, you mentioned plasma and vaporized hydrogen peroxide, and you said or. Do you use those words interchangeably, plasma and vaporized hydrogen peroxide? Because I know on their website it's vaporized hydrogen peroxide, but not plasma. At least you have to kind of look in a couple different areas. Are those the same?
It is one and the same. In fact, plasma is more like a jargon used for hydrogen peroxide. sterilization process, because hydrogen peroxide is the name of the chemical actually used. It's a sterilant used in a chamber to sterilize packages, while plasma is actually part of the whole process, is plasma that helps in the dispersion of the hydrogen peroxide.
Mm-hmm. Can you explain, there's different types of process indicators. Can you explain the different types and how they're different from one another in the sterilization?
Yes. There's 6 categories of sterilization indicators. They all vary, and they used to be referred to as classes. Now they are referred to them as types of indicators. Type 1, 2, 3, 4, 5, and 6. The number doesn't necessarily imply that one is better than the other. It's just purpose of one versus another is different. For example, type 1 chemical indicator is a process indicator. That one is used, it's an external indicator used in packages that are being sterilized or reprocessed, where it just shows you that this particular package has gone through a sterilization process. It does not determine whether it's sterile or it's not. It just serves a very specific purpose of telling the user that if a surgeon or a dentist or someone grabs the package with instruments in it, looks at the package, on the outside of it has a chemical indicator, it will show that chemical indicator has changed color from one to another, for example, blue to black. Mm-hmm. And if they see a black, they know that it's been processed through a sterilization process. Type 2 chemical indicators, those are not necessarily used with the packages. They are in fact used more in determining whether the equipment, in this case, for example, steam sterilizer, is functional. You have Bowie Dick packs, are referred to them, for example, where you have a sheet of chemical indicator ink printed, and then it is trapped in between layers of various categories of paper, where it's put in a sterilizer daily, for example, or however the schedule works in the processing departments in hospitals, for example, where they then determine whether that machine has been good enough to evacuate all the vacuum or the air out of the chamber, so that they see uniform color change in this Bowie Dick pack. And if that's the case, then they can use a sterilizer to actually process packages that are going to be used on patients. Type 3, it's basically just monitors one condition. Let's say it will just measure temperature. And they say one would be a wax pellet in the glass, where it just within a specific temperature it will melt, or it will measure one single condition. When you go to type 4, 5 and 6, a lot more, those are referred to as internal indicators. Type 4, for example, will be an indicator that is inserted or pre-printed inside of the package, for example, pouch, mm-hmm. or a reel that is used to sterilize instruments in it. You'll have a mark inside of the package, or you have a strip that is taken and inserted inside the package that will also contain an external indicator, process indicator, the type 1 I referred to. In that case, then, the purpose of that indicator inside there is to determine whether the saturated steam, for example, in the case of an autoclave or steam sterilization process, whether the saturated steam has penetrated the package, or the instrument that you have inside has seen the same conditions as this indicator. And if those conditions are not met, it will not signal properly. So it measures 2 critical parameters. For example, in the case of steam, time and temperature. In the case of ethylene oxide, it can measure time and ethylene oxide concentration, or temperature and EO gas concentration. Type 5 indicators would be indicators that would measure all 3 critical parameters: time, temperature, and in the case of a sterile EO, or in the case of steam, saturated steam, which is sometimes in the industry referred to as dry steam, which is somewhat misleading, because you don't want steam that is wet and is going to drip all over the packages, because in fact that inhibits killing all the bacteria or viruses that are potentially in a package. So the purpose of these indicators is basically to replicate the performance of the biological indicators. In the case of a type 5 indicators, these indicators are not necessarily used to clear the packages to be used, but they are supposed to measure the equivalency of a kill rate on the any viruses or bacteria that may be within those cavities or any other parts of the instrument that is being sterilized. And type 6 are emulators, where you have a little pellet, for example, trapped between two layers of different foil and semi-permeable paper, for example, and then with time, temperature, and steam will slowly melt and travel. It's a capillary reaction, and it travels all the way to reach a certain area of the window where it has an opening where you can actually read it. So all these indicators serve a specific purpose. Okay, so a type indicator, the easiest thing probably for people to remember would be is if you go to your dentist and you see on that tray a little pouch with a paper film combination of it, you may want to have a look and ask your dentist, can I have a look and see how the indicator changed color?
Right, yeah.
And in that case, you'll see that actually it has changed from one color to another. And if it did not, maybe that package should not be used.
Yeah, right. Yeah, verify the verification
Exactly.
device. So they're obviously serving a purpose, but then they're also, I guess, serving like a meta purpose of reducing hospital-acquired infections. At the end of the day, it's all about like reducing infection, right? And then the question I wanted to lead in is, what are the headwinds or tailwinds in the market? So you mentioned all these different types of indicators, steam, hydrogen peroxide, formaldehyde, dry heat, whatever. Which ones are you seeing growth area in, or what do you see as some growing, some not growing, or what's happening in the market in terms of
I'll be glad to address that too, because we kind of see trends and where they are headed. But it was very interesting you pointed out the healthcare acquired infections or hospital acquired infections, and according to the Center for Disease Control and Prevention data, just very few years back, a number of annual infections in the U.S. is roughly about 700,000 infections a year, or about 3% of the people who walk into the hospital facility for a service.
Yeah, all those surgeries, all those elective surgeries.
Yeah, we're talking about surgeries, talking about lots of them have to do with infections that otherwise would not happen. But I don't want to scare people and say, no, well, you don't go to the hospital because you're going to get infected. In fact, only about 50 to 70% of them are preventable in an ideal condition. And that trend has grown where there has been significant improvements. However, still in a range of about close to 70,000 people a year die from hospital-acquired infections. And as far as the usage of these indicators and where the trends are going, obviously steam sterilization process is the most predominant process still in use today. It is very robust. It is very, it has no toxins whatsoever in the process, and it has proven over and over again to be probably the most reliable of all, because once you have a package that steam can penetrate, and pressure and temperature and time combined, they will destroy the DNA of any bacteria or viruses contained in the instruments being sterilized. Ethylene oxide, on the other side, there's trend to kind of, it has tapered off and somewhat a slowdown just because of the toxicity of the ethylene oxide. However, in very controlled process, is very efficient in killing bacteria and viruses. The reason some of these other processes even exist in the first place is because you have a lot of instruments, think of endoscopes and lots of different tubes and whatnot that cannot be steam sterilized. They cannot survive the temperature. You're talking about 250 Fahrenheit or 121 C. Or and there's another cycle in steam sterilization which is 274 Fahrenheit or 134 C Celsius. And some of these devices cannot withstand steam sterilization. So you need to now fall back onto another process. The one that is gaining probably the most attention of all lately is, for the last quite few years now, is plasma or hydrogen peroxide, because at the end of the process there's no toxic chemicals being used in the process, yet hydrogen peroxide has proven to be very efficient in killing all the bacteria and viruses and denature them in the process of sterilization. Some challenges exist as to being able to disperse the gas throughout the instrument that you're sterilizing. Mm-hmm. However, that's still, it is becoming very popular in hospital settings, especially when it's also quick sterilization process, unlike some other ethylene oxide, for example, where you need to pull out the packages and have them aerate, and then there's a pretty long process to ensure that there's no ethylene oxide left inside the package or the instrument that someone will be using. So they want to move towards less toxic or no toxic processes, and plasma would be one of them.
Isn't the advent of more electronic, like small electronics in surgical instruments, like an instrument that might have electronics in, also a factor in hydrogen peroxide? Because I think
absolutely,
I've heard that. So obviously, high pressure moisture and steam doesn't bode well for anything that has an electrical circuit.
That's a great point, actually. I forgot to mention that actually electronics would be another one of those. If the reprocessed instrument contains electronics in it, you cannot expose it to steam sterilization. Right. First of all, you'll destroy probably the electronics part of it. And you're talking about very high moisture. It has to be 100% humidity in there. Mm-hmm. So you're talking about very high concentration of moisture in there. That's the only way that actually the reaction between the moisture, time, and temperature there will kill the bugs. Mm-hmm. And electronics cannot withstand that.
What are some of the compliance considerations? And when you look at, with the end-use environment of these things, what are some of the hurdles from a regulatory standpoint that people need to kind of get through? So if there's a product team that's working in this space, what are some of their challenges from a compliance or regulatory standpoint for these types of products?
Glad you brought it up, because unfortunately, still market is littered with products that don't seem to be as robust and compliant as they should be. And the standard that kind of governs the performance of chemical indicators is ISO 11140. And that's been adopted throughout the world now. They make certain adjustments to it. Each, for example, country or region may have certain modifications to the process to make them even more stringent. But you're talking about AAME, for example, in the US, that has adopted the same conditions. Because think of this way, a pouch, that simple pouch I referred to, a dental office, it's a medical device. Mm-hmm. And it has to be cleared. You have to have a 510K pre-market notification clearance in order to actually use that or distribute that product in the market. And there's very specific conditions. For example, for a process indicator, at 10 minutes and 121 Celsius or 250 Fahrenheit, it has to change color. At 2 minutes, it must not. Well, I don't know. I challenge some people to go out there and test some of those products, whether they comply or not.
Right.
Type 4 indicator, however, for example, manufacturer says that this product will change color at 14 minutes, or 10 minutes, or 16 minutes, or whatever that time they set. Minimum has to be 10. They set for the chemical indicator to change color. Now your window of product not changing color is going to be the time you set minus 15%, minus 25% in the case of type 4. In type 5 case, you're talking minus 15%. So that now the 10 minutes becomes 7.5 minutes, must not change from 2 minutes on the type 1. So the performance criteria are very stringent. Going around the world, in some places you see that chemical indicator labeled as type 4, 5, or 6, and you put it in a steam sterilizer for 5 minutes and probably changes color. It just tells you that it's probably not compliant. And it is unfortunate because there's ways to monitor and establish performance criteria. Yes, it does require a lot of work, and some places do a better job than others. But the performance criteria are critical in order to really be able to count on that chemical indicator performance. It is an excellent tool to have a visual inspection as to if something should or should not be used and reused again.
Yeah, and obviously on the manufacturing side, because that's obviously the world that TapeCon's in, is making sure that those inks are properly prepared, printed the right way, and then all of the regulatory and compliance check boxes are checked during the production process to guarantee, I'll say, a repeatable result, so that in the end use they're performing properly.
Yeah.
So there's my shameless plug, but that's okay.
Yeah. The only comment I'll make on that one is that I wish, I haven't had an opportunity to visit TapeCon multiple times and see the detail and attention paid to doing things right. It's refreshing compared to some other places that around the world use these same inks, and because you can give TapeCon and a company B the same ink, and the outcome of the two possibly on the same substrate, printed on the very probably same machine, may not be the same, and likely won't be the same because their control processes are not in place.
Yep. Thank you. The what's new, or is there any, as kind of a wrapping up the podcast here, but anything new at Laco Temple Inc. that you want to talk about in terms of any new exciting things in the hopper, new products, or if you want to mention, a little bit more details of some of the other inks that are in the portfolio that are out there that you're selling?
Well, I'll go back in time a little bit, because as great of a job as Temple did for so many years, first of all with inventing the inks and being a leader in technology development for these categories of inks, when Laco acquired Temple in 2013, they literally just put all the might and force behind not only maintaining that quality standard, but also refreshing the product lines, improving the quality, tightening the control criteria, specs, quality control, and put a lot of focus on developing new families of inks within these same categories or new categories of inks that have come out ever since. And we've done a lot of work in improving the existing, for example, steam category of inks, ethylene oxide inks, security inks, for example, which we touched briefly on, process of developing brand new families of those inks to meet the challenges of today's world. Because think of security and that money pouch, and not that many people are willing to do that, but if somebody's given a pouch full of cash to transfer from point A to point B, it still unfortunately happens that somebody's in kind of things like, maybe I could pull a few of those hundreds out and reseal it back, and there's ways people try to tamper with, and incorporating some safety features in those inks that signal properly, signal timely, in cooperation with adhesives used in the package and whatnot, are critical. We're also worked very hard on the new product line for just general printing inks, because what we have heard in the market very often is that these packages that I'm producing, yes, this ink does not need to change color, does not need to have any specific features, but specific features as in, it has to change from red to black or blue to green or whatnot, it has to withstand very harsh environment within which these packages or products or labels are exposed. Well, think of steam, think of other processes where these packages are brutally exposed to very harsh conditions, and these inks must not migrate, must not transfer, must not bleed. A lot of things criteria need to be met in order for the ink to be truly good. You don't want that ink to be transferred onto a medical device. You don't want to be transferred onto an instrument that's going to be used into someone doing a heart surgery and cause secondary, possibly fatal issues. So that general print inks have been a new category we added a few years back, and we are expanding on that. And also we are looking into any new technologies that may, come into market.
Good. That's exciting stuff.
Yeah, very much so.
Well, that's about it, Pjeter. Thanks for coming on the podcast in person, and appreciate you having here. I'm excited to, continue our time here today while you're on site. So, any final parting words, I guess, for the audience before we kind of wrap it up? And obviously, I want to thank you again for coming on.
Well, first of all, thank you very much. I really appreciate the opportunity. I'm passionate about these types of products just because of maybe my background, but also seeing and learning what's going on in the market and going to these hospitals, going to that sterilization department in these hospitals, knowing what those folks go through, a great job they try to do, and making sure that those guys have a good, compliant product is critical. We're talking about patient care, and it's hard to overemphasize the importance of chemical indicators and good products being used. Yes, the converters like TapeCon have a responsibility of making sure that they are used properly and within guidance given by us or any other manufacturers of the inks, but there's so many criteria that need to be met and so many things that need to be lined up properly in order to have a successful conversion of product. I'll just leave it with the last thing I'll say is TapeCon and some others who really pay attention to detail and how they do the work are going to make a difference in the market. And we look forward to working with you very much so.
I really appreciate that. I'm excited for our employees to listen to this podcast because, if you're running the product or in the ecosystem of the product realization part that we're in at TapeCon, it's always nice to step back and look at kind of where the product goes in the end environment and kind of bring that kind of meaningful work back to it. So I appreciate all the context on that, and I'm excited for people to hear this. So thanks, Pjeter, for coming on. And for those listening, I'll do a recap at the beginning of the episode. And thanks, everyone, for listening. And thanks, Pjeter.
Thank you very much.
Okay. The Better Products Podcast is about educating product teams about new materials and new technologies, all in the custom material converting and printed electronic space to help them design and build better products. So in this podcast, I'm hoping to give wide-ranging conversations with various people throughout the industry and just bring a lot of good content to the table. So if you're interested in learning more about the industry, materials, processes, how to improve products if you're on a product team, or just general know-how of what the heck is going on in this industry, then subscribe to the podcast and get ready for some more really good episodes as I bring in some great guests. Thanks.